Hi everyone, this is a quick pre-teach for 5.2 Ready, Set, Go. Number 1 for the topic here for the ready, for numbers 1 and 2 and 3, you are just going to identify which of the given points to the solution make the equation true. And so you're going to plug these points in up to here and you're going to say does it or does it not. So for example, this x comes before y in an ordered pair, so this is your x. You're going to plug it in here. 3 times 2 is 6. You're going to plug your 4 in for the y. 2 times 4 is 8. 6 plus 8 does not equal 12, so therefore a is not a solution. For 1, 2, and 3, there are going to be more than one possible answer. For numbers 4, 5, and 6, you are going to find the point that goes here that does make this solution true. So in other words, you're going to plug 2 in for x and rewrite this problem. So you're going to say 2 plus y equals 6. And then you are going to solve it like a two-step equation. You could even use the box method. You're going to minus 2 from each side. So y has to equal 4 in order for this solution to be true. You're then going to do that for 0. You're going to plug 0 in. 0 plus y is 6, so y is 6. And then you're going to plug 0 in here. 6 plus 0 is 6. You're going to continue that, solving each of these using either the box method once you've plugged in or solving equations. Okay, for number 7, 8, 9, and 10, this is just like 5.1, except for this time, instead of equations, we have inequalities. As a reminder, if you have an inequality that is greater than or less than, then your line that you graph is going to be dotted. If you have an inequality that is greater than or equal to or less than or equal to, then your line that you graph is going to be solid. So this line right here is going to be a solid line. This one right here will be a dotted line, and again a solid line. But I'm going to go ahead and I am going to pretend like this is an equal sign while I graph. And so I am going to say, I'm going to start at 4. From the origin, I'm going to go up 1, 2, 3, 4. And then I'm going to go 3 for every 1. So I'm going to go either up 1, 2, 3 for every 1, or I can also go down 1, 2, 3, and backwards 1. And since I said that's a solid line, I'm going to connect and make this solid. Now the difference between an equation and an inequality is I'm going to be shading one side of this inequality. So I need to figure out what y can be that is smaller than this. The best way to do that is to plug in the origin, 0, 0. So I'm going to plug the origin in, 0, 0, into, oops, that's my x, and this is my y, and rewrite my equation. Is 0 less than or equal to 3 times 0 plus 4? Well, 3 times 0 is 0, and 0 plus 4 is 4. So my question is 0 less than or equal to 4? If you answer yes, then you shade the side of the origin. So since my answer was yes, when I plugged in 0, 0, it was true, then I'm going to shade this side. If I would have said no there, then I would have shaded the opposite side because the origin would not be included. Let's do another one. Let's do number 9 because this is a fraction. So I'm going to start at the 2, which will be from the origin. I'm going to go up 2. And then remember this one, the numerator tells me how far to go up or down. So I'm going to go down 3 and forwards 5. So from here I'm going to go down 1, 2, 3 and forwards 1, 2, 3, 4, 5. And I'm going to, since that does not have an equal sign under it, it's going to be a dotted line. So it's going to be something like this. I should be using a ruler, but I don't want to get up and get one right now. Now, I need to know, am I going to shade the side of the origin or I'm going to shade the opposite side? So I'm going to take this origin here, that 0, 0, and I'm just going to plug it in and say, does it make the equation true or does it not? Oops, I did it again. So is 0 greater than negative 3/5 times 0 plus 2? Well, this right here becomes 0. So is 0 greater than 2? The answer is no. So here's my origin. Since I said no, I'm going to shade the side opposite of the origin. Okay. Now you can attempt that on numbers 8 and 10. Here, number 11, remember this right here means it is going to be greater than or less than on a number line is going to be an open circle, and greater than or equal to or less than or equal to is going to be a closed circle. When you do this, you are going to have to solve for x. Okay, so you are going to either do the box method or you are going to solve the equation. Remember, when you multiply or you divide by a negative number, we learned this right before school was out, then you have to flip the inequality. So when you have multiply or divide by a negative number, you are going to flip that inequality. So give this one your best shot and we'll go over it on Friday. Okay? And then you had some questions here about that same problem. Same thing here. 4x minus 2y is greater than or equal to 6. It says solve for y. I'm going to do this one for you to get you off to a good start. So I'm going to get y alone, which means I'm going to subtract 4x's. Because remember, I have to ask myself, how is it attached to my y? Well, it's attached with addition or subtraction. So if I subtract 4x's from here, I'm going to subtract 4x's from here. So my new equation is negative 2y's is greater than or equal to negative 4x's plus 6. I just flip these around because the x should come first. It's just proper. Now I need to take away that 2 from that y is attached with multiplication. So I'm going to undo it with division of a negative 2. Means I have to divide this one by negative 2 and this one by negative 2. And since I divided by a negative, I've got to flip that inequality. So my equation is going to be y. This is now going to be is less than or equal to negative 4, and a negative 2 is a positive 2x. And a 6, positive 6 and a negative 2 is a minus 3. There's my equation that I'm going to graph down here. Remember, since it is greater than or equal to, it is going to be a solid line. Okay, and then use this equation here to walk you through the rest of those steps. I hope this helps get you a good start on your Ready, Set, Go.